Alright, so here we are at the workstation where every single trigBoard that comes in is inspected, factory programmed, and functionally tested, all right here. Now, with the popularity of the trigBoard, it would take forever and possibly risk human error if they were tested all by hand manually by exercising the inputs. And this is really important to me though. I wanted every board to be 100% tested before it leaves here. So I created some very simple software over here in a test jig so that the technician just needs to plug the trigBoard in and run through the software and everything is automatically tested and verified. So in this video I'm going to show you how all that software works, and you can create your own software to test your own products as well. This is very easy and cool. So let's check it out. Alright, so here we are at the jig, and I know it doesn't look pretty, but this thing works great for what it does. And again, we're testing the trigBoard, which is an ultra low power platform for the ESP32. So we've got an ESP32 on there to factory program, as well as the ultra low power front end to the board with all of its features to test. So let's just kind of run through this. I'll go through it step by step, and then after we'll dig into the code and I'll show you how the whole thing works. So we'll take a fresh board from the contract manufacturer, slide it into the jig, which connects up to a USB to serial converter, which is monitored by the software. And then we've got this little cheater plug here that gives power to the board from a calibrated power supply off camera, and it's feeding exactly 3 volts to the board, while the other input is fed from a relay here that we also control from the software from another USB to serial converter. So this one, when it receives a command, we've got a little AT Mega 328 board down there, so we send commands to it to basically just toggle this relay, and that is used to not only exercise the contact input of the trigBoard but also to wake it up for factory programming. So let's go ahead and run through that. I'll plug this in. We've got power to the board. We go up to the software here and you see new board, press reset and check current. So we'll do that, press reset. Check the power supply, we see all zeros on it, so we're good. There's no shorts on the board or anything weird going on. Hit next, and you hear that little click there, and you might have saw the light flash. That is toggling that relay to wake the trigBoard up. So it exercised that contact input, wakes the trigBoard up, and now it's actually flashing the ESP32. And you probably can't see this on camera, but below here the RX and TX LEDs of the USB to serial converter are flashing, so it is flashing the board, and it actually does two things. It first erases the ESP32, then flashes the base firmware. So it's actually a two-step process. Okay, up at the software we see flash success, so press reset button, press the reset button, and now it's mounting the file system from the base firmware, and we'll then start running the code. There we go, battery success, and testing timer, so we wait 5 seconds for that. Timer success. Cool. Testing contacts now with the relay. And contact success. And now it's saying press and hold the wake button for, well, we'll just press and hold the wake button. So we press the wake button. You see wake success. Now set up converter. We're going to hold the wake button until we see the LED flashing. It's flashing. And now we go over to the configurator, click connect, and pair up with this brand new trigBoard, and you see this is a special version of the configurator that's calibrating the battery, setting the timer, and all of the default parameters here within the configurator. Complete, and this one is done. We click disconnect there. We go back over here to the software, click next, check meter for zeros. We got all zeros, meaning that the low power functionality of the board is working properly. We hit next, and it tells you your total time, great job, you earned money, and then you're ready for the next board. So I know all of that seemed really chaotic and fast, but let me just kind of slow things down and I'll explain what actually happened there. So the software controls everything via these USB to serial converters, and there's actually 3 on the board. So we've got one obviously for flashing the ESP32, and then we've got this one which is simply used to toggle the contact input to the trigBoard from this little relay here, so that's pretty easy. This one over here I haven't mentioned yet, but this is another ESP32 board that is acting as a gateway. So the way this works is by default, I have the parameters set in the trigBoard to wake up every 5 seconds and send a UDP packet out to a default SSID and password, which happens to be hosted by this guy here. So it'll wake up every 5 seconds and send packets to this guy. So that's kind of cool. It's actually exercising all of the Wi-Fi functionality within the chip itself. So when it actually is testing the timer and the contacts and the wake button and all that stuff, it's actually doing that by physically checking to make sure that the packets received over here line up with what we're doing over here. So for example, when it erases and flashes and then it mounts the file system after you press the reset button, it's immediately going to start executing code. And the first thing it'll do is send out a contact is still open or contact is still closed message. And it does that every 5 seconds. So you're testing, are we getting the correct contact message over? Are we getting it within a certain time period? So it's testing the timer as well. And then, since we have control over this relay, we can actually open or close and then open the relay here and make sure that when we wake and send the packet over to the gateway that it's all correct. And while we're at it, it also checks to make sure that the battery voltage looks about right and all that stuff. So just overall make sure that everything is functional and working properly on the board. And then when you saw me go to the configurator, the reason for that is not only to test that the Bluetooth works, but also it calibrates, it does a single point calibration of that battery voltage by looking at the offset, and it takes an average of about 20 readings and then applies that offset automatically. And it also changes those values, because when you get the trigBoard, I don't want it to have UDP enabled by default, waking every 5 seconds. So it turns all of that stuff off because it's only used for this first initial test. So once we load the configurator there, it automatically will go in and change all of those things, turn them all off to normal default values for you when you receive the trigBoard. So it's not too bad. It takes about 2 minutes, less, sometimes 90 seconds or so to get all of this done. So not too bad at all. And that's everything there is to how this board works. Now, I was thinking, this power supply I have over here is actually pretty advanced, and it has an RS-232 port on it. I could even tie the software to that to make sure that the current readings are right, so that even the user doesn't even have to go up here and check the power supply. So anyway, that's how the factory programmer automated tester works here. So let's go ahead and dive into the code, and I'll show you how all that works. So here we are. It shouldn't be any surprise to see that this was all written in processing, which is one of my favorite tools to create quick and dirty apps like this. And it's very powerful too. You can make things look very clean and professional if you want to. So anyway, I want to just run this straight out of here to kind of show you what happens on launch. So it first directs you to the folder where all of the files are. So you see here, we select the folder, so I dump everything in here, trigBoard firmware. And you see there's not just a bin file, there's actually everything you need to flash the file. So let's go over to the Arduino IDE for a second. So you see here, when we do the tools drop down and we select the exact board we want with all of the settings, and also just in your preferences, you want to make sure that you have the verbose outputs here selected. And what I want to show you real quick, and I've talked about this in the past, is if we go to click upload, this will fail, which is fine. And all we really want to grab out of here is this last line, which is the instruction to flash the firmware. And the reason I'm showing you this is just so you know how to do it, because this app here I created is just a one-off that runs just on this Mac computer here. So if you're running on some other system, with different settings, you're going to have to tweak this. So let me show you how to do that. So I grab that last line, we'll paste it in right here into a text editor. And I just want to point out everything you need here. So you see, you're going to need this Python file here, ESP tool. So we'll go and grab that. You see the chip that it's selecting is the ESP32. The port is the serial port, and I'll talk about that in a second. The baud rate and then some settings with resetting here, and the command is going to be to write to flash. The flash mode, the flash size, none of that we care about. We are going to carry all of that over into our GUI. And then some of the files. So you see we've got this boot app bin, so we go and grab that. You also want the bootloader bin here, and then the actual files here. So you've got your application bin, so we're going to grab this. And then also the partitions bin. So you grab all of these files, and the reason I do this is so that this thing can be totally standalone and not require anything else. And also, more importantly, is what if what if you change something? What if, you made an update to whatever and something changed and you didn't test it? So that's why I also like to do this. So it's this kind of frozen setup here so that every board that leaves the jig has been programmed exactly the same way. So I just wanted to show you that. Let's go back over to the GUI here. So again, when we hit the play button and we launch this, you've got all of those files. Now I had to rename the bin file here. So the main bin I call the bin, like that. And you'll see in the code where we hunt through the files, and you can change this to whatever you want. But you see the bin file, we've got the partitions bin, we've got the boot app bin, the bootloader QIO bin dragged in there, and then also the ESP tool Python file as well. And then this file, old tool, don't worry about that. I was kind of tweaking things. It turns out I just updated this Mac here to Big Sur today, so I had to actually make changes already as to how this works, which is again why I'm going through this show. So if you're going to try to do it on your own, you know kind of the steps on how to set all of this up. Okay, so we select the folder, hit open, and now like I mentioned before, we've got 3 serial ports here to actually choose, and we have to tell the software which is which. Now the way I did this is I plugged each one in separately and wrote down on a little sticky note here like which one is which, so that when I launch the software I know what to do here. So the first one you see trigBoard port, and we'll go D on that. The next one is the relay port, which is C, and then the gateway is on B, so let B. And that's all there is to it. So now when I click next, you see what's happening down here. It's flashing the software. It's running that same exact command we had from the Arduino IDE, but all from command line within this software. And there it goes. So the first thing it did was erase the flash, and I'll show you that. And now it's actually writing to flash. And it's nice because we can have this little debug output over here. So everything that was echoed back from the Arduino IDE, down below here, if I scroll over, down below here is now shown in the debug output from the processing sketch. Okay, and then, we press the reset button, and it's mounting the flash system, and will then wake up and send out the contact is still open right there, and checks the battery. Battery is good. Contact has closed. Contact still closed. So it's going through all of the steps, testing everything out. And these messages are coming in on the gateway serial port. And we'll go through all of this stuff. So let's go ahead and press the wake button just to complete the test. There you have it. Cool. Okay, so let's dive into this code. And I'm going to go through this pretty quickly here, so we'll just skip through some of these things and get into where things actually start to happen. So here you have the setup. And the first thing we really do is go and open that file folder. It presents that pop-up there to navigate to where that folder is with all of the bin files. So you see we've got a function here, get files. And if we go to the tab files, you see all this function does is select folder, and that's what launches that little pop-up. And then basically, it'll go right past this and start going into the codes, which is why I've got this infinite loop here, just waiting until the bin file name actually changes. So when it, is changed to something else, finally it'll get out of this. So that's why I've got that there. And when we actually select the file folder, this function down here is called folder selection. So if I go down here to folder selection, we go in here, and this is when it gets the absolute path for where that is. So we've got this folder, it lists out all of the file names, and then loops through them and checks to see if any of the files contain any of these names. And if they do, they're going to assign those names or those paths to the appropriate variable names. And I've got these back here, so let's just scroll up a little bit. So all of those names, all the files we need, 1, 2, 3, 4, and 5, are strings here, variable names, and we're going to use those to create that huge string that even the Arduino IDE uses. So when we went back here, I already got rid of it, paste it back in. So each one of these is a full path, to these files here. So like the ESP tool is that full path, and we're going to use that. So that's what the whole purpose of this function down here is. So it's looking for the boot app, the bootloader, the ESP tool, partitions, and then I have one just called the bin, okay? And so you can call that whatever you want, but the reason you can't change it to anything else is because, well, I guess you could probably get a little creative here with the code, but the partitions bin has the same name as the main bin. And just to go back to it, so what I mean is that if we actually have this sketch here, if it actually had a title, it wouldn't be like this, sketch NOV138. It would actually have a name to it. But anyway, the partitions bin has the same name as the main bin file here. So that's why I had to totally change the name to something else, because .contains would always be true for both the partitions bin and the main bin. And I'll just go to that folder real quick so you can see it. So there it is with all 5 of those files. Don't forget about old tool. In fact, I'm just going to get rid of that altogether. So I just renamed this one the bin.bin. Alright, so that goes through and we get the absolute path written to each one of these string variables here. So now we can build that out and execute to the command line that full line there to flash code to the ESP32. But we can't do anything unless we have our serial ports. So we've got down here in the serial tab, we've got a way to launch a pop-up and select serial ports. And I've used this code over and over and over again in all of my processing sketches. I don't even know where this came from. It came from maybe some example somewhere up on the processing reference page. But if we call this here serial selection, and I actually pass in the name of the port that we're looking for, and all that does is when you play here, we'll launch the app here, open that. All this does, the string name of port, is really just putting this at the top here, trigBoard port, so you know what you're actually selecting. So this goes through and lists out all of the available serial ports, and then we'll return the actual name of the report. Name of the port. So you see return serial.list. So this is whatever you put in there, whatever letter you put in will return the actual name of that port. So let's do that again. So if I put in D for this, it's going to return that full path. Their dev, USB serial, DN, blah, blah, blah. And we get that, and now we can use it in the code as part of that complete path when we're writing to the command line to write or to flash the ESP32. And we do this for the trigBoard port, the relay port, the gateway port, and then because the trigBoard port's actually being handled by that Python script that flashes the ESP32, we don't actually need to open it from the processing GUI here, but we do need to control the relay serial port and the gateway serial port. So we actually open those up here with their baud rate 115/200 for each of those, and each of those of course are 2 devices that we also have code, and I'll pull that up. It's very simple code. Okay, so now we're in the loop or the void draw function, and this just loops on forever, and we only actually ever do anything as long as there's no failure. If we do have a failure, we'll go down here to the else of this whole thing. It will just draw a red screen and show failure with what the failure mode was, which is right here. So background would be red, and it will just put some text on the screen showing what the failure mode was. And then we always draw the 2 buttons like you saw there, the reset button and the next button in green. So those are drawn very easily right here. You see we have the dark red for the reset button, or the restart button, and then also for the green button, which we only show in various states, because while it's doing an automated thing, there's no sense in drawing the next button. Like if we hit next right now, you see the next button disappears. And how do these buttons work? Well, we're just drawing rectangles with text on top of them. So what we actually have over here in the mouse click tab is anytime you click the mouse, it's going to check and see if you're on top of the restart button or the next button, and only, again, if you're in various states will it actually do anything like reset timers or advance to the next state. Alright, so I got a feeling this video is going to be a long one, so let me just quickly kind of burn through this code here and explain only really the important bits. Like, you know, this first step here in flashing the firmware is kind of important. So, you know, we're at state 0, and you see everything is kind of handled with these states, and it just increments on through 0, 1, you see here, and then 2 is in there because it erases first, then it flashes, 3, then it waits for that reset button, goes on through, increments to on through to 3, then 4, you know, so it's kind of this huge state machine just incrementing on through. So only if the current state is equal to whatever will it advance to this next, to each of these states. But anyway, let's go back up and let's explain how it actually erases the ESP32 and flashes that base firmware. So it was at the current state 0, you press the next button, it advanced the state to 1, and now we're flashing firmware. And it's going to do this by calling here the erase function. So we'll go over to the flash commands where we have void erase. Okay, so this is what it's going to do. It's going to write this to the command line. So this whole string here is what's written, and this is exactly what the Arduino IDE had, except we're building out that string here manually. So what we're going to do here, ESP tool name is that, let's pull that up. It is the esptool.py, so this is that Python script, and in there is a way to erase the flash. So the command here is chip ESP32, the port is what we selected for the trigBoard. You see the baud right there, the commands before default, reset, after hard reset, and the command is erase flash. So that's the complete string, so it's going to erase the flash there. And then this is kind of cool here. We'll skip this line for now, but this is kind of cool. I found this as a way to print out what the response is in that from, you know, executing that in the command line. So that is all handled down here. So while we're reading in the line here, we're printing that out down here, showing what's happening. And we can also check it. So as soon as we see it try to open the serial port, what we're going to do is toggle the relay, because again, we've got the trigBoard down here. It's an ultra low power device. It's actually controlling power to the ESP32 by the sensor inputs. So we actually toggle the relay to wake it up before we do anything. So as soon as we see that that Python script is trying to open the serial port, we'll toggle the relay and it'll wake the trigBoard up so that it can flash it. And if you've been working with the ESP32 for any amount of time, you've always noticed that at the end of it, of flashing it, you'll see hard resetting via RTS pin. So in this loop, as soon as we see that, we know that things are good. We know that it passed. So that's why we set this Boolean erase success to true. We're all done. We can then put the relay back to the open position and then return back. And then the same thing occurs for flashing the code. So what we're going to do now is try flash, and this is in the same tab over here, so flash. And it's the same kind of deal, except now that whole string is changed. So we've got the same tool, the port, the baud rate, and then now we're building that out even more with those bin files. So you see, we've got all of those bin files right there, just the same way as we saw them from the Arduino IDE. So it's the same exact kind of setup, and we're going to print that out to the command line, wait for the the output from it to tell us, when the serial port opens. We're going to toggle that relay, and I'll talk about how we're toggling the relay in a second here, but don't worry about it. Just know that when we write a C to the port, it's going to close the contacts, and O, it's going to open them. We're waiting for that hard resetting via RTS pin. We know everything is good. Open the contact, clear out the port, and we're going to increment the state. At that point, we're happy, we can move on. And you will notice that there's timers everywhere in this thing, because if we don't get anything after we get this, we know that there's something went wrong, because as soon as you are complete here, you're supposed to press the reset button, but if you don't, it's going to time out and fail. Like everything in this automated software, everything is based on timers. If we don't expect something within a certain period of time, we're going to fail. Yeah, I know I'm kind of like rushing through this code here at this point, but it's funny, I'm thinking as I'm working through this how complicated some of this software is. And it's funny, even in my career, I've seen, facilities where there's racks and racks of National Instruments gear, and it's all just for the automated test equipment. It's almost like more engineering goes into the automated test equipment than the product itself. It's kind of a funny thing, but this side of engineering is sometimes, I think, more exciting than the product development itself. Anyway, I'm rambling. So we got a successful erase, we got a successful flash, and you see there's checks everywhere in here. So all of those booleans, if they're ever false or there's ever a timeout, we're going to set the failure mode here, the failure boolean true. It immediately will go to that red screen and show what failed. So the failure mode, flash failed or erase failed. So you're going to see that all throughout here. Here's one timer fail, so as we just go through this, everything is checked against, what it's supposed to be. So now we're at this point right here, and we're simply waiting for now you press the reset button, and as soon as the file system mounts on the ESP32, we're supposed to get a contact is still open or closed. We'll actually go to it now. Okay, so now we're sitting at current state 3, and at this point we're waiting for the user to press the reset button so that the file system can be mounted on the ESP32, and then it'll start running code. And it's got that 5-second timer that's waking up the trigBoard every 5 seconds, checking the contact state, and it will send a message over to the gateway via the UDP packet, and it will say something like contact is still open. And at that point at the gateway, it's going to send it over the serial port to the software. We're going to receive that and check it. So within 5 seconds here, after we're in this current state 3, we better see that. And if we don't, after 30 seconds, we know that there was a timer fault. And you see here we've got the 1 second flasher here. So it's flashing between, so we're flashing green, white and green back and forth there. And you see it flash success, waiting, press the reset button. You've got 30 seconds to do so. And if there's anything on the gateway serial port, go and get it. So let's go over there. We've got serial get right here. It's going to read it till we get a new line. And I've got some samples here of what we should see on that serial port. So if we're in current state 3, we better expect trigBoard name contact still open in that string. So as soon as we see that, we pull it out. We're good, we're happy with that. But hey, also the battery voltage comes over. So let's check out the battery voltage. So we strip that off of it. We get rid of the V character at the end of that, and we have a float battery voltage. And, if we're going to see a failure of the battery voltage, it's going to be like pinned to 0 volts or 4 volts, its maximums. Or I think it's like 5 volts is the maximum. But anyway, it better be within this range because we have a calibrated power supply feeding it exactly 3 volts. So it better be within this range. And if we see that, we're happy. We see a battery pass. And now we're going to start testing the contacts. So the first thing is we close the relay contact by writing a C to it. And we increment the current state. Otherwise, we got a battery fault. So battery fault, fail, and failure mode true. So now we're at current state 4, and now we're waiting. We throw up battery success, and now we're waiting for the contact still closed message to appear, and we're sitting here waiting for that. And if we don't see anything, we're going to fail, of course. So serial get over here, we'll go there, and you'll see if the current state is 4, we better see this. And if we do, now we open the contact, we'll wait for that, and this better have been received within this time here, because it is a 5-second timer, so better than, or greater than 4,000, less than 10,000 milliseconds. And we're going to then increment the state, and now we are down here at a timer success. And this just pops up only for 2 seconds, just to show that, yep, we've got the timer. The timer was good. Now we're going to move on and increment to current state 6. And this is when we will actually check for the contact. So it's going to use the relay now to first close, and then it's going to show, it's going to close it and then open it, check all of that. I'm not going to go back over to the serial tab because it's doing the same thing as before. It's just making sure that everything that comes over from the gateway is right from the trigBoard. And again, this is all done wirelessly. So when the relay is closing its contacts or opening, it wakes the trigBoard up and is physically waiting for that message to be received by the gateway over here wirelessly, and then that sends it from its serial port to the software where we read it in and make sure everything is right. Alright, so hopefully this is making sense. So we're now at current state 7, moving on through, and it only shows this up for about 2 seconds. And then we wait for the wake button. We've got 30 seconds to wait for the wake button message to appear at the serial port. Same kind of deal. Anything goes wrong, it fails. And then finally, now we're at current state 9, and this is when you use the configurator to go and launch that, and it calibrates the battery and preloads it with the default values. And then current state 10 is the meter check, and then current state 11, we're all done. Finally, great job, you earned money, and that shows for only 5 seconds, and then resets the current state back to 0. Oh man, that was a lot. So, and I'm kind of breezing through this. So anyway, that is the full GUI. Let me now show you the code real quick that's on the 328 and on the gateway. Alright, so the 328 code is dead simple. So you see here we've got a digital pin on 2, which is actually going to this little relay module. I don't even know where I got this from, but it's just simple little relay board that from digital pin 2 turns this relay on, closes its contacts, and that just goes over to the trigBoard. We've got its serial port 115-200, and look at how easy this is. If we ever see anything available, if that character red is an O, means open, so write that pin low. Otherwise, honestly, you can write anything you want, any single character. We'll write that relay high there and close the contact. So I just write an O and a C to this, and that's it. Alright, here's the gateway code. Very simple. This was actually, I think, copied out of a one of the examples that comes along with the ESP32 core. But you see here, I'm using those default values in the trigBoard here. So your UDP SSID is the actual SSID here that's hosted by the ESP32. Your UDP password. So it just launches itself as an access point. Server.begin, and it's going to listen on UDP port 1234. That's all there is to it. And when a packet comes in, all it does is write the packet right out to the serial port. That's all there is to it. So as soon as we send a packet, a UDP packet on port 1234 from the trigBoard, it's received right here and out it goes. That's all there is to it. Not much to that code at all. But it does fully test the trigBoard, so that's kind of cool. You know, this is one of those videos that at the end of it, I'm feeling like I didn't explain this code long enough, and at the same time, I feel like I explained it too much. You know, like this video's got to be so long by now. If you're still hanging in there with me, feel free to leave a comment below. That'd make me feel better that somebody's still out there watching this. But I hope you found this interesting, and I have made some I wish I could show you, but they're all for confidential projects. But I've made some gorgeous GUIs with this processing stuff, and I've made it look just beautiful with, all running on a Raspberry Pi, nice touch screen, and it actually talks to other hardware, and it's all self-contained. And people love this too with the Raspberry Pi because you can have like 10 of them in stock, so if one goes down, pull another one out, or at least keep all of the different images on SD cards. So if anything goes wrong, throw a new one in, you're good to go. So anyway, a lot of cool stuff you can do, and I love using this for factory programming and tests. So anyway, I thought I would share this. If you got any questions, you want more detail, if you want more detail, yep, let me know in the comments below. Thanks for watching.